So welcome back. This is the second part to the 6.1 video. And in the first part, I showed you about the different types of equations, the 5 different types. In this second part, we're going to look at balancing these equations. Okay, so this is called balancing equations. And when you balance a chemical equation, it's using the concept of the law of conservation of matter. The law of conservation of matter says that matter cannot be created or destroyed, only changed. So we're going to use this concept to make sure that everything that we have on the left side of the reaction, we have the exact same thing on the right-hand side of the reaction. So what do I mean about that? Well, let's go ahead and write out this equation. So it says that solid aluminum, oops, let me get a smaller pen. All right, so solid aluminum is heated, leaving aluminum chloride, sorry. So aluminum chloride is AlCl3. All right, so aluminum chloride is heated, leaving aluminum metal plus chlorine gas. So that's Cl2. All right, so what we have on this side as the reactants, on this side of the arrow, we have to have exactly the same atoms, the same number and the same kind. Okay, so the way we do this is by adding what is called coefficients. So a coefficient is a large number that's in front of an element or compound. So this would be called a coefficient in front of the compound or element. And that equals out. It acts as a multiplier that multiplies all of the elements in that compound, and it will equal out what you have on the left and right. So there's a couple of tricks to balancing chemical equations. The first trick is that you always want to balance carbon first and oxygen last. Carbon first and oxygen last. Well, if we look at this equation, we don't have carbon or oxygen. So we can balance these in any order we want. So what I do is underneath this arrow here, the yields arrow, I'll write the elements that we have to balance. So and I'll just start like reading a book, start at the left. So we have aluminum that we have to balance, and chlorine that we have to balance. Okay, and then I start counting. So on the left-hand side of the equation, I have 1 atom of aluminum. So I'm going to put a 1 there. And if I look on the right-hand side of the equation, I also have 1 atom of aluminum. Okay, so I have 1 on both sides. That's great. That's already balanced. Okay, so now I'm going to look at the chlorine. On the left-hand side, I've got 3 chlorine because that subscript there tells me that I have 3. So I have 3 on this side. And over here on this side, on the right-hand side, I've got 2. All right, so that is not balanced. That is not equal. So we're going to have to make it equal. So I'm looking here, what common factor does the 3 and the 2 have so that it will make it equal? Well, that's going to be 6. So in order to make 3 chlorine here be 6, I need to add a 2 multiplier, a 2 coefficient in front of the entire compound. I cannot squeeze it in here. You cannot put numbers in between the elements of a formula. You have to put it at the very front of the formula. So if I put a 2 there, that makes 6 chlorine. So looking over here on this side, I need 6 chlorine. Well, I've got 2. What can I multiply that by to get 6? And the answer is going to be 3. So that's going to make 6 chlorine on this side. All right, so now the chlorine is balanced. But sometimes when you balance an equation, it throws off something that you've already balanced. So if you'll notice here, we have 2 aluminums now. So you have to back up and backtrack sometimes just a little bit. So over on the right-hand side, I need to make 2 aluminums as well. So I need to put a 2 there, which makes a 2. All right, and so what you need to do before you say, okay, this is balanced, is you need to go back and check one final time to make sure that everything is okay. All right, so I have 2 aluminum on this side, and I have 2 on this side. I've got 6 chlorines on this side, and I've got 6 chlorines on this side. That is what we call a balanced chemical equation. So let me get all of this junk out of here. All right, so balanced chemical equations. You cannot just write a chemical equation. From this point forward, when you see a chemical equation, you have to make sure it's balanced. Now, on a test or a quiz, if I give you coefficients that are already in front of elements and compounds, then you can just go ahead and assume that that is correctly balanced, unless the question is saying, is this a correctly balanced chemical equation? Then you have to go back and check it. But if I'm giving you an equation that you use to do something else for a problem, and it doesn't tell you to make sure it's balanced, then you can assume that it's balanced correctly. Okay? All right, let's do another example. We have solid phosphorus. And remember from yesterday, that's P4. And sulfur, and again, that's S8. You wouldn't know that just by phosphorus and sulfur. And this is going to combine to form tetraphosphorus trisulfide. All right, so P4S3. All right, so copper and oxygen are not in here, so we can just balance these the way we see them. Phosphorus and sulfur. So we have 4 on this side for phosphorus, and we have 4 on this side for phosphorus. So that's a check. We have 8 here for sulfur on this left side, and on the right side we have 3. So that does not check out. We have to make that equal. All right, so we have to look and see what is the common factor between 8 and 3. Well, if we double 8, that's 16, but 16 is not divisible by 3. So if we multiply 3 8s, that's 24. So let's see. So 3 does go into 24 8 times. So it looks like the common factor here is 24. So I didn't mean to erase that. Let me go back and put it back in. So in order to get 24, we had to multiply sulfur here by 3. Okay, so that's going to make 24 sulfurs. And over on this side, we can't squeeze in an 8 right there, so we have to put it in front of the whole thing. So 8 times 3 makes 24. All right, so look what that did to the phosphorus. Okay, that also changed the phosphorus here. So 8 times 4 is 32 phosphorus on this side. So we have to go back and make 32 on this side. So 8 times 4, so that's going to be 8 over on this side as well. Okay, so that's going to make 24. All right, so I'm going to check just to make sure everything checks out here. Okay, so I'm going to go back and check my work just to make sure. So 8 times 4 is 32. 8 times 4 is 32. Okay. 3 times 8 is 24. 8 times 3 is 24. All right, so that checks out. It's the same on both sides. So my balanced chemical equation for this is 8 P4s plus 3 S8s yields 8 P4S3s. Okay. All right. So aluminum metal is placed in a solution of zinc chloride to form zinc metal and aluminum chloride. All right. All right, so we have aluminum, zinc, and chlorine. I'm going to move this down right here. We know that that does not take place from yesterday's notes, so we're not even going to balance that because that reaction doesn't happen. All right, one aluminum here, one aluminum here. That checks out so far. One zinc here, one zinc here. That checks out so far. Two chlorines here. Three chlorines here. All right, so that does not check out. So we're going to have to make sure that chlorine is balanced. Erase my little underlines. So a common factor between 2 and 3 is 6. So I need to make 3 times 2 is 6 on this side, and 2 times 3 is 6 on this side. So that changed my zinc to 3. So I need to add a 3 here to make zinc 3. And this made aluminum 2 on the right-hand side. So I need to put a 2 on this side to make that aluminum 2 as well. All right, so that's a balanced equation right there. All right, so it's your turn to do this. So what I want you to do is let's get this equation written out and then pause the video and see if you can balance it by yourself and then come back and look how I do it. All right, lead 3 nitrate, so that's Pb NO3 3 plus potassium phosphate K3PO4 yields lead phosphate, so that's Pb. All right, and phosphate's PO4, that's a -3 charge. And this was lead 3. All right, so we don't need any subscripts because they're both 3. PO4. Okay, so you have to make sure you have proper formulas. If you don't have proper formulas written down, then it's not going to balance correctly. So you need to make sure, if you need to review that, make sure that you can do it. KNO3, those are both +1, -1, so that just smashes together. All right, so before you start balancing here, this is polyatomic ions that we're dealing with. Here's a hint. Whenever you're balancing polyatomic ions like this, check to see if it's on both sides. If it's on both sides, don't break it up into nitrogen and oxygen. Balance it as a polyatomic ion, a full polyatomic ion. Okay? All right, so pause your video and try to balance this. Okay, so here we have Pb, because we don't have carbon and oxygen. And oxygen, when I say oxygen, I mean oxygen not in a polyatomic ion. We don't have oxygen by itself. We have NO3, nitrate ion. We have potassium, and we have the phosphate ion. So that's how you're going to balance it. So if you didn't do it this way, go ahead and pause your video again and try to rebalance it and see if you can do it. If you did write these out as polyatomic ions like this, then you can just keep going and watch. All right, so we have 1 lead on each side. That's balanced. So we have 3 nitrates here. And we only have 1 here, so I'm going to put a 3 there to balance this nitrate ion to make it 3 on both sides. Okay. All right, so now we're going to balance the potassium. We have 3 potassium on the left. Now we have 3 potassium on the right. Okay, so potassium balanced itself out because we added that coefficient there. And then phosphates, we have 1 phosphate on this side, and we have 1 phosphate on this side. Okay, so it looks like just adding that 1 coefficient there balanced everything out, but we're going to check, go back and double check just to make sure. All right, so 1 lead here, 1 lead here, 3 nitrates here, 3 nitrates here, 3 potassiums here, 3 potassiums here, 1 phosphate, 1 phosphate. All right, so that is a balanced chemical equation. Okay, right there, balanced equation. Okay, so I did skip over one equation, and that's this one. And the reason I did not start off with combustion is because combustion is a little bit different. There is a trick to doing combustion reactions, and I'll show you why. So let's go ahead and write this out. C2H6 plus O2 yields CO2 plus H2O. All right, so this does have carbon and it does have oxygen. So we're going to do carbon first and oxygen last. All right, so 2 carbons on this side. We only have 1 carbon on this side, so I need to add a 2 there to make 2 carbons. Okay. All right, so here's where it gets a little tricky. We have 6 hydrogen on this side. We have 2 on this side, so I need to add a 3 there to make 6. What you have to look for is sometimes there's going to be the same element on both in 2 different compounds. Like say, for example, this over here, we could have had, it's not really hydrogen that gets tricky, it's the oxygen. So sometimes over here, we have C2H6OH. So we have oxygen here and here in both of those elements and compounds in both of the reactants. So you have to make sure that you count carefully so you don't miss anything. And sometimes it happens with hydrogen too, but it just didn't happen on this one. Okay, so oxygen, we have 2 on the left-hand side. Now, oxygen is in both of these. So you have to make sure that you count them both. So 2 times 2 is 4 plus 3, so that's 7. 7 oxygens on this side. All right, so this is why I wanted to balance this one last. Because since we only have 1 oxygen on this side and it's a multiplier of 2, that means that this left side here is always going to be an even number of oxygens. But look, on this side we have 7. There's no way, if you had to multiply it by 2, there's nothing that we can do to get this to be 7. So there's a little trick. Okay, and here's the trick. We can multiply a number by 2 to get 7, but it's just not a whole number. So what number can we multiply by 2 to get 7? How about 3.5? 3.5 times 2 does get you 7. But now you're thinking, can I have 3.5 molecules? Can I divide a molecule? And of course, the answer to that is no. You cannot have a half a molecule. They all have to be even numbers. Okay, so I'm going to go back and I'm going to make sure that this is balanced. And then I'm going to show you how to fix that. So technically, right now, this should be a balanced equation. 2 carbons, check. 6 hydrogen, check. 7 oxygen, 2 times 2 is 4, plus these 3, that's 7. Okay, so that is, in all technicality, this is a balanced equation, but we cannot have a half a molecule. So think math. How can you get rid of a half to make it a whole? Multiply it, everything, by 1 number. That's going to be 2. All right, so if we multiply all of our coefficients by 2, then we should get a balanced equation still. So 2 times this one, so we're going to have 2C2H6 plus 2 times 3.5 is 7 O2s. 2 times 2 is 4 CO2s. And 2 times 3 is 6 H2Os. All right, so let's make sure everything is balanced. 2 times 2 is 4 carbon, 4 carbon. 2 times 6 is 12 hydrogens. 6 times 2, 12 hydrogens. 7 times 2 is 14 oxygens. 4 times 2 is 8 plus 6. 8 plus 6, 14. All right, so there's your balanced equation. So that's the little half, I call it the half trick, half oxygen trick, and then go back and multiply everything by 2 to get that whole number. All right, so that's balancing equations. We have a whole 17 problems on yesterday's homework that you can practice balancing equations. That's what that blank is for. You might have to get a separate sheet of paper and start using that to balance your equation. You will get to a point where you can just look at an equation and not have to write the elements underneath the arrow here like this, where you can just look at both sides and balance it. But until you get to that point, writing them out like this is very, very helpful. All right, so make sure that you click that like button, slap it right across the face, click subscribe and the notification bell so you know when I put videos on YouTube before I put them on Canvas. See you in class.